So the third question on Leibniz theorem would be something like y is equal to e power x into log x. We have seen two questions in the previous two videos of this playlist. The link is in the description. Please go watch that first, and then you can come here to have a more comfortable understanding on this video. Okay. So for now, this is our last question that I'm going to see on Leibniz theorem. And the description of the video, I've given many practice questions. If you're feeling that I want more to practice, I want more questions to practice with solutions. In the description, just click the Google Drive link, and then a PDF will open where you can find many problems on Leibniz theorem. Those problems plus these three problems that we have seen in this playlist is more than enough for you to solve any questions on Leibniz theorem. Okay, so let's continue. So y is equal to e power log x. E power x into log x. Okay, so this is clearly in the form of u into v. Okay, u into v, because Leibniz theorem tells that if anything is in the form of u into v, where u and v are two functions multiplied together, then this is the Leibniz formula that you should apply in order to find the nth derivative of this expression. So here y is equal to e power x into log x. Here you can clearly see that u will be e power x, and then v will be log x, right? Yes. So the Leibniz theorem clearly says that we need some data to find. We need u, we need vn, nc1, u1, vn minus 1, so on and so forth. There are many terms. This dot representation tells that Leibniz theorem has many terms in it till this is the last term. This will be the last term, and in between the first term and last term, there'll be many terms like this: nc1, nc2, nc3, nc4, whatever, n4, u4, u5, so on and so forth. So that's what this dot representation means. So let's try to first of all start with u. Let's find u1, u2, u3 first, and then let's go to vn minus 1, vn minus 2, and then let's find nc1, nc2 and all that. Okay, so let's start with u. Okay, u is this one. Okay, and we need u1. We need u1. So u1 is what? What is u1? u1 is the first order differentiation of u. U is e power x. So differentiation of e power x is e power x itself. By the way, all the basic differentiation formulas that is required to solve Leibniz question is given in the description below. Just click the link. Just by heart those formulas. Those are more than enough for you to solve any kind of engineering mathematics problem on Leibniz Leibniz theorem. So u1 would be e power x. And then what? And then u2 would be, because we need u2 also. We need u1, u2, u3, e4. It goes so on and so forth. U2 is what? U2 is differentiation of u1. U3 will be differentiation of u2. U4 will be the differentiation of u3. So u2 is the differentiation of u1. U1 is e power x. And differentiation of e power x is again e power x. U3 will be differentiation of u2. E power x. Again e power x. U4 will be differentiation of u3. U3 is e power x. Differentiation of e power x is again e power x. So you can clearly see that every single u until un will have e power x. Only e power x, e power x, e power x, and e power x. Because differentiation of e power x is e power x itself. So all the u1, u2, u3, all the possible u's until un, including un, infinite, like including the last term, would be only e power x in this point. So here is a very important point that I should address. So in the previous two videos of this playlist, we came to know a condition where at some point u was 0. If you remember, please watch the previous two videos for those people who haven't watched. So I think in the video 1, I think u4 was 0. Since u4 was 0, only u1, u2, and u3 was required. Since only u1, u2, u3 was required, we had only u1, u2, u3. Basically, the first term, this term, and this term that has u1, u2, u3 would be present in the final solution. From here, only like 1, 2, 3, 4 terms would be present in the final solution, because this is a endless, it can have many terms. So considering, just assume that if u4 was 0, then only u1, u2, u3 would be is given to us. It's there for us. So because of which only these u1, u2, u3, the terms which has u1, u2, u2, and u3 would only be present in the final solution. From u4, it's going to be 0. U4 is 0, right? Yeah. And if u4 is 0, u5 would be 0, because differentiation of 0 is 0. u6 would be again 0, because differentiation of 0 is again 0. So from u4, if u4 is 0, from u4, all the u's from there would be 0, 0, 0, and 0. So because of which every term from here also would be 0, 0, 0, 0. Because if u4 is 0, this entire term is 0. Because it's a multiplication, and 0 multiplied by any term would be 0. Since u5, u6, everything is 0, from this term, every term would be 0. And henceforth, only 1, 2, 3, and 4 terms would be present in a final solution. All this is if u4 was 0. But in this case, none of the u was 0. In the previous question, the problem 2, I think u2 was 0. If u2 was 0, only u1 was there for us, because of which only this term and this term was present in the final solution. But in this case, none of the u's are 0. None of the u's are 0. Instead, every u is having only e power x, e power x, and e power x as its value. So in this case, what to do? In this case, it is absolutely fine to have this dotted representation in a final answer as well. Yes, just find some just find some first three terms, which is this and this. Just find nc1 u1 vn minus 1, nc2 u2 vn minus 2, of course un vn. Once you get all this data, just form these first three terms, and then you can put plus dot 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 and this final term. Yes, if none of the u's are turning 0, which means it has endlessly, how many ever terms, god knows, we don't know. Because of which it's absolutely fine to have this dotted representation in the final answer. Since here none of the u's are 0, now for this solution, the final answer for this nth derivative will have a dotted representation. I'll tell you at the end of the video. Keep watching this video. At the end, when I'm forming the final solution, you will see what I mean. Okay, fine. Now, another very important point. It is not always mandatory that all the u's are same. You can have different values for different u's, and still there cannot be any use that is not 0. You know what I mean? See here, none of the u's were 0, but still every u had the same value. I'm saying that there can be cases where all the u's are different, but still none of the u's are turning to 0. In that case, same thing. Just find the first three terms, and then put plus, and then dot 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 dot, and then just put this last term. That will be a final answer. That's all I want to tell. Just a clarification. So let's proceed. We got u1. Since this solution is going to have this dotted representation, I'm interested to find only the first three terms. Okay. So u1, u2 is over. First three terms as in we need u1 and u2. Okay. So that is done. Now let's try to find vn, vn minus 1, and vn minus 2. Okay. So v is log x. So don't you think this can be written as log x plus 0? Why did I write this as like this? Because this is a standard derivative. By the way, I have already made a video on nth derivative of standard functions. The link is in the description below. Please go check that out. You'll know what I mean. For those people who haven't watched, chill, watch this video. Nothing great and all. It's very easy. After this, you can go watch that video. Standard function means nothing but there is a fixed formula. There is a direct formula that you can apply for log x, because according to this formula, look here. Log of ax plus b. Isn't this in the form of log ax plus b? Look here. Log ax plus b. In place of a, there is 1. If the coefficient is nothing, which means it's 1. Plus as it is there. In place of b, there is 0. So this is in the form of log ax plus b. So we have a direct formula to find the nth derivative of log x plus b. Just we'll apply this formula and we'll find vn. Am I right? We'll find vn by that. Okay. Let me write the formula here. If y is equal to, okay, log of ax plus b, that implies that the nth derivative is given by the formula minus 1 to the power n minus 1, n minus 1 factorial a power n by ax plus b whole power n. Okay, this is the formula that we are going to apply here to find vn, because v is in the form of log ax plus b. Okay, so in the place of a we have 1, in the place of b we have 0. Okay, so I can say that a is 1, and then D is 0. Okay, let's put A and B in this formula and let's find the nth derivative of log x. Okay, A is 1, B is 0. So just put here wherever it is. So Vn would finally be like n minus 1 into n minus 1 factorial into yeah uh, into a power n, right? What is a? 1. Okay, a is 1. So 1 power n, okay, by ax plus b. A is 1, so just x plus b is anyway 0. So just x will be remaining, x to the power n. This is the final answer, right? Yeah. So this, yeah. So this is Vn. Fine. This is Vn. Yeah. Okay. 1 power anything is 1 itself. So I can just, it's okay. I'll keep it just to show you, let it be like 1 power n. No, not a problem. Okay. And then once we got Vn, it's very easy to find Vn minus 1. Am I right? So what is Vn minus 1 going to be? Wherever there is n, in the place of n, put n minus 1. So minus 1, in place of n, put n minus 1. N minus 1 and this minus 1 as it is. Okay. So it's same thing here. In place of n, put n minus 1 and this minus 1 as it is. I mean, this minus 1 as it is, factorial. And then 1 power anything is 1, so I'm not going to write it, by x to the power n. So this is nothing but minus 1 to the power n. Minus 1 will become minus 2. Same thing, n minus 1 will become minus 2 factorial by x to the power n. So this is Vn minus 1. Similarly, let's find Vn minus 2. Why? Because our target over here is to find only the first 3 terms, because anyways it's going to have this dotted representation in its final answer. So to simplify it as much as possible, I'm not going to be interested in finding the 4th term, 3rd term, 5th term and all. Just give it a little bit, I mean, just to write a final answer for the sake of writing, let me find the first 3 terms. You can even find the first first 4 terms, first 6 terms if you have the time. If you have the time to find all the 6 terms, go for it. But in examination, you don't have much of the time. So since anyways, I'm going to write the dotted representation here. Let me just find first 3 and then put dot and put this last term. Okay. Yeah. So Vn minus 1 done. Let's find Vn minus 2. So Vn minus 2 is same. In place of n, okay, in Vn expression, in place of n, wherever there is n, put n minus 2. Okay, so that will be minus 1 to the power n minus 2 minus 1. Okay, same thing. In place of n, here I put n minus 1, here I'm putting n minus 2. That's it. N minus 2 minus 1 factorial by x to the power n minus. I'm so sorry. Yeah, I'm so sorry. In the previous n minus 1, right? We have to put n minus 1 here as well, because n is there here also. Okay, so in place of n, I'm putting n minus 1. I forgot that. I'm so sorry. So now it's correct. X to the power n minus 1. Yeah, x to the power n minus 1. Here it will be x to the power n minus 2. So if you solve this, minus 1, n, minus 1 minus 2 will become minus 3. N minus 2 minus 1 will become minus 3 factorial by x to the power n minus 2. Okay. So we are finally done with u1, u2. We finished. We already have it directly here. Okay. Vn, yes, we have. Vn minus 1, Vn minus 2, we just now found out. Only thing left out is NC1 and NC2. Let's find out. That's very easy. Okay, NC1 formula is NCR is equal to n factorial by n minus r factorial into r factorial, right? Yeah, same thing. In place of r, there is 1 here. So n factorial by n minus 1 factorial into r factorial. R is 1, so 1 factorial. So n factorial, I can write it as n into n minus 1 factorial. And in the denominator, I have another n minus 1 factorial, and 1 factorial is just 1. So this both will cancel and n minus 1 will be remaining, which is nothing but n itself. So if at all, I mean, most of the people who are watching this video would understand what I did, right? So if at all you are not understanding how I simplified it, the way I simplified it, go watch the first video of this playlist. I have clearly explained to you very slowly about how you should be solving the NC kind of I mean, whenever there is a variable like n, how you should be solving the NC or NC1, NC2, NC3 kind of sums. So you'll get a clear explanation. The first video of this playlist, go watch it. The link is in the description. So NC1 is over, okay? NC1 is over. Now let's find NC2. That's all. This is the last thing that we have to find. And once we find, let's put all the values here and finally write it down. NC2 is nothing but n factorial by n minus 2 factorial into 2 factorial. So n factorial, I can write n factorial as n into n minus 1 into n minus 2 factorial by n minus 2 factorial. Okay, will cancel, and then 2 factorial is 2 itself. So this is nothing but n into n minus 1 by 2. Okay. So we know everything now. So just put everything here and finally find the final answer. Find the nth derivative. So putting all the data that we have calculated in the expression, we'll finally get yn as e power x. Okay. I'm not going to spend much time on explaining this step because I'm just substituting it. So that's no need of explanation. I'm directly writing it fastly, quickly, into n minus 1 factorial by x to the power n plus e power x into n into minus 1 to the power n minus 2, n minus 2 factorial by x to the power n minus 1 plus n into n minus 1 by 2 into minus 1 to the power n minus 3 into n minus 3 factorial by x to the power n minus 2. And then plus. I told you, right? I told you. Let's just find first three terms. Okay. Yeah. First 3 terms and then put dot, dot, dot and finish it up with the last term. So first 3 terms I have already done. See, 1, 2, 3. First 3 terms and then plus dot, 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 dot. Okay. And then the last term, we have to finish it with un into v. Un is, what is un? Yeah. See, I told you, right? U1, U2, U3, U4, all the way till un, the value is always going to be e power x. For this particular case, for this particular question, un is always going to be e power x. So I can assume as, e power x as un as e power x. So e power x into, what is it? Un into v, right? So v is nothing but, we have it in the question itself. V is log x. E power x into log x is the final answer, nth derivative, okay? Nth derivative of e power x into log x. So I made a separate video on this because I have to show you the case where none of the u's are turning 0. Okay. Suppose if u4 would have turned 0, we would have had a finite number of terms in the final answer, which is u1, u2, u3 we would have got. And because of that, u1, u2, u3, which means first term, this term, this term, this term. 1, 2, 3, 4 terms would have been present in the final solution. But in this problem, none of the u's were turning 0. So if at all you encounter this case, okay, your final answer can have this kind of generic representation with dotted things. I'm so sorry, we need plus here as well, okay? You can have this dotted representation to just represent the series, okay? No problem. And then I also told you, right? And I also told you that there can be cases where U1, U2, U3 are all different. In this case, it's all same. So luckily, it was much simpler this time. So there might be case where U2, U3 are all different. So in that case, nothing. Just find the first 3, just like this, and then just form this. Put plus plus plus, and then finish it off with the last term. Okay. So this is the mostly won't get like that, I guess, because none of the questions I've seen till now were all u's were different. Either it will be same like this, or at some point u will be 0, where you can find the finite number of terms in your solution. So either it will be all same like this, or either some u will be 0, which will clearly tell you that only these many terms are going to be present in your final solution. Okay. Yeah. So that's all with this last problem of Leibniz theorem.